Section 10.6, solve equations with radicals. All right, so remember when we're solving equations, we're simply trying to figure out what's the x. And usually we need to isolate the variable. Well, that's true. We are going to do that. But first, we're going to isolate the radical. We got to get the radical by itself, and then to undo that radical, we're going to raise both sides of the equation to the corresponding power. Remember, when we're solving equations, we can do anything we want as long as we do the same thing to both sides. You know, I always say that. Okay, so here we go. Let's start with the square root of x equal to 9. Well, step one, the radical is already isolated. It's already by itself. So in order to get back to just x, we're going to have to square it, right? Because the square root of x squared is x, right? Because x to the 2 has power equals x to the 1 power, which is just x, right? So I square x, square root of x, and I square 9, so now x equals 81. All right, and on these, it's going to be important to put the answer that you get back in. You know that anytime you solve an equation, you can also always put your answer back in for x and find out if your answer is correct. On these, it's going to be important because sometimes, even though the numbers come out like it should be correct, it won't be correct, okay? And you'll see it as it goes. But just put it in your brain or on your paper, either one. 81 square root of 81 is 9. Yes, it checks, and we're good to go. Keep moving. All right. This one is also, the radical is already isolated, and so we're going to do the same thing to both sides. In this case, we're going to undo the radical by raising both sides to the corresponding power. The power is 3, or the root is 3, so the power needs to be 3, okay? So in order to come up with, well, the cube root of y cubed is just y. And it's the same reason with this. So y to the 3, this is y to the 3/3 power, which is just y. All right? So we have to take negative 2 cubed. So we end up with y equal to negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And so we put it back in just to be sure. The cube root of negative 8 is negative 2 times negative 2 times negative 2. And there is a triple. So we have negative 2, and that is true. So we're good to go. Move on. Okay? Same thing here. If it has more than just one anything, you can't add that 7 first because this isn't 7. This is the square root of x minus 7. So you've got to square that entire radical. And so now when you square the entire radical, what you have is just x minus 7 equal to 8 squared. 8 times 8 is 64. And so now you've got an equation that's simple to solve. You're going to add 7 to both sides. And when you add 7, x equals 60, 70, 71. Is that right? 60, 70, 10, 11. Yes. Okay. So then what you do is you put it back in. 71 minus 7 is going to be 60. Is that right? 8, 9, 10, 11. It is. All right. 71 minus 7 is going to give us the 64. Square root of 64 is 8. We're good to go. All right. Moving on. So the same thing happens if you have a binomial under a cube root. You're just going to cube it. So now the cube root of x minus 3 cubed is just x minus 3. Negative 1 cubed. Negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Add 3 to both sides. So x equals 2. Put it in, and I know you're going to get complacent because a bunch of them, most of them will come out and they'll have answers. But I promise you, keep going. So 2 minus 3 is negative 1. The cube root of negative 1, negative 1 times negative 1 times negative 1, yep, is just negative 1. Good to go. X equals 2 is our final answer. All right. 2x plus 1 square root equals negative 3. Square both sides. So we get 2x plus 1 equals negative 3 times negative 3 equals positive 9. Subtract 1 from both sides. 2x equals 8. Divide both sides by 2. I hope I'm not going too quick. You can do these. These are just quick, easy solving steps once you get to this step. Divide by 2, x equals 4. So now go back in, because we're not complacent yet. Put the 4. 4 times 2 is 8. 8 plus 1 is 9. The square root of 9 is 3, not negative 3. So what you'll do in this case is say 4 is an extraneous solution. Extraneous, extraneous solution. So in this case, there is no solution. All right? So it's a null set because we've got an extraneous solution. All right. Finally, we get to one where we need to use step 1, isolate the radical. All of those others, the radical was already isolated just to get you in the mode of we got to square both sides. So now you can't square both sides because this is not part of the square root. So you're going to first add the 10 to both sides to isolate the radical. So now you've got the square root of x minus 3 equal to 11. All right. Now you're exactly at any of these steps. All right. This is a square root, so you're going to square it. So now x minus 3 equals 121. 11 times 11 is 121. Add 3 to both sides. X equals 124. Check it just to be sure. 124 minus 3 is 121. The square root of 121 is 11. So it checks out and we're good to go. All right. Now, wait. There's more. What happens if... I think this one came first. I can't remember. Oh my goodness. All right. What happens if we have the square root times a square root? And you're going to say, oh no, we can't do this. But you know what? We can. It's really actually not as, it really is not as difficult as it looks. It's actually simpler than a bunch of those. Haha. Because both of them are square roots. When you square both sides, you don't even have to do any computation. All right. When you square a square root, you end up with just what's inside that square root. So this is just 4x minus 5 equals 6x plus 5. Ta-da. All right. So now simply solve that. Subtract the 6x from both sides. So negative 2x minus 5 equals 5. Add 5 to both sides. Negative 2x equals 10. Divide both sides by the negative 2. So x equals negative 5. All right. Now go in and check it. Don't forget to check it. All right. So you're going to go in and you're going to put in the negative 5 everywhere you see an x. So negative 5 here and negative 5 here. So 4 times negative 5 is a negative 20. Negative 20 minus 25 is a negative 25. And actually right there you can stop, because you need the square root of that negative 25. And what do you know about this, the square root of a negative number? You can't do it. So over here, or we can't do it yet. You will be able to it. So this would have been negative 30. So negative 30 plus 5 would also give you a negative square root of 25. But we know that we can't get a real answer here. So because this is no real solutions, this is extraneous. And we have no real solutions. All right, here we go. One more. Square root of 3x minus 2 equals the square root of 8 minus 2x. Same thing we just did, a little bit different, but the same type of thing. So see if you can do it. Do it real quick on your paper. See if you can beat me. Because we're going to square both sides of the equation. Remember, you can do anything you want as long as you do the same thing to both sides. So we end up with just 3x minus 2 equals 8 minus 2x. Add 2x to both sides. 5x minus 2 equals 8. Add 2 to both sides. 5x equals 10. Divide by 5. X equals 2. And now we're going to check it by putting it in 2 here and 2 here. 2 times 3 is 6 minus 2 square root equals 8 minus 2 times 2 is 4. 6 minus 2 is 4. Square root of 4 is 2. 8 minus 4 is 4. Square root of 4 is 2. 2 equals 2 is a true statement. And so x equals true checks out. Yay, I like it when they check out. Makes me happy. All right. I think that's everything. So don't forget, in order for this to work, the radical has to be by itself on one side of the equation. If there happen to be 2 radicals, one on either side of the equation, that works also, but you can't have extra whole numbers in your equation and then square both sides. All right, so isolate the radical, raise both sides to the corresponding power, and then solve. You can do this. See you next time.